So today let us discuss about finding the structure of documents. So in natural language processing, words and sentences do not occur randomly. Obviously they do not occur randomly. We are going to give them a structured arrangement to form the sentences, right? So that is what is written here. In NLP, words and sentences do not occur randomly. Instead, they follow a structured arrangement forming meaningful units. What are these meaningful units? They might be statements, requests, or commands. So, the topic is finding the structure of documents, right? So, extracting the structure of the documents is essential for NLP tasks. Like, it is useful in many things like ASR, like automatic speech recognition, or OCR, which is optical character recognition. Automatic identification of the document structure supports tasks as parsing, machine translation, and semantic role labeling, which means that our topic is only finding the structure of documents, right? So, finding this structure of document is very essential for our NLP tasks, and it helps in parsing, machine translation, and also semantic role labeling. Additionally, identifying sentence boundaries improves the readability of outputs from systems like ASR. We already discussed this. So we have two main subtopics involved in identifying document structure. Those are sentence boundary detection and topic boundary detection. Let us now discuss about the sentence boundary detection. So sentence boundary detection is nothing but we just have to know when the sentence is ending. Okay. So it is a process of automatically dividing a sequence of word tokens into sentence units. So if I have a whole sentence, then each word is known as word token, right? So we're dividing the sequence of word tokens into sentence unit. If I have 2 or 3 sentences, then I have multiple word tokens, right? So I'm dividing those sequence of word tokens into sentence unit. This is one sentence, this is one sentence, this is one sentence, like that. Next is working. So in written text, sentence boundary. So next is working. So in written text, sentence boundaries are typically identified using capital letters at the beginning of a sentence and punctuations like period, question mark, and exclamatory mark for the ending of the sentence. Now let us go through some challenges of it. The first one is abbreviations. See, if I say Dr. Smith or APJ Abdul Kalam, I have periods on it, but it is not the end of a sentence. So it is not a boundary. That is the first challenge that we face. Next is multiple uses of a punctuation. See, for example, let's take period only. It is used in abbreviations, it is used in decimal numbers, it is used in proper names, and it will make the segmentation of boundaries harder because we have multiple uses of the punctuation. Next is informal text. So for example, if you text your friend on WhatsApp, then your English wouldn't be in a proper grammatical structure. It lacks proper punctuation marks and grammar, so it will be harder for segmentation. Next is errors in input systems. See, if I have like ASR, which means automatic speech recognition, it will give me many errors when it converts my speech into text. For example, Google Keypad, Google Voice. If I on it and talk for some time, and then when I check my translation, it might have many errors in it due to my pronunciation or slang. So the text generated by OCR and ASR systems may contain errors affecting boundary detection. The last one is code switching, which means usage of multiple languages. Like if I in a single sentence, if I use both Telugu and English, or maybe Hindi and English, next is code switching. So code switching is nothing but if I use both Hindi and English together in the same sentence, or maybe Telugu and English in the same sentence, then it'll be affecting punctuations and also sentence structure. So it will be harder for sentence segmentation. Just remember it like this. Sentence boundary detection is for sentence segmentation. Topic boundary detection is for topic segmentation. Okay, now applications. So also one more thing, the sentence boundary detection is done before the pre-processing step. So it is used as a pre-processing step in NLP tasks such as parsing and machine translation. It also improves readability of outputs in speech recognition systems, helps in structuring text into meaningful units of further processing. We already discussed all these points above. Next is topic boundary detection. See, this before sentence boundary detection is about when the sentence is going to end, right? Topic boundary detection is about when the topic is changing. For example, I have a paragraph which consists of 4 sentences. The first 2 sentences are about sports and the next 2 sentences are about music. So the context is being changed, the topic is being changed. So the topic boundary detection should divide or make a boundary after the first 2 sentences. So coming to the working of topic boundary detection, it identifies boundaries where the topic changes in sequence of sentences. That is what we talked, right? When the topic changes, we have to identify a boundary. Operates on sentences rather than individual words. So it mainly focuses on sentences and not on individual words. Assumes that topic changes do not occur within a single sentence. So it is saying that within a single sentence the topic won't be changed, right? It will gradually change with the number of sentences increasing. Now let us discuss about the applications of topic boundary detection. Information extraction and retrieval, text summarization, segmenting long documents into smaller meaningful parts so that only relevant segments are retrieved based on the user queries. Coming to the challenges and limitations, determining exact topic boundaries is difficult because topic transitions may be gradual. For example, if I talk about sports, then I might talk about swimming, then I might talk about the swimming methods instead of different sports, or maybe talk about what happened during swimming, like challenges that I faced during swimming, etc. So the topic has been gradually changed. So determining exact topic boundary is difficult. Requires identifying semantic similarity between sentences like meanings. Depends on features and training data for accurate segmentations. Thank you.